This is FRM Part 1, Book 4, Valuation and Risk Models, and the chapter on multi-factor risk metrics and hedges. The last chapter was called the one-factor risk metrics and hedges, and so we're just going to add a couple of factors here. Remember, in the previous chapter, we spent a lot of time talking about duration. We'll do the same thing here, but we're going to add a couple of really interesting things about duration. We need to take a deep breath. There are some complex parts to this chapter, and we'll spend some good time talking about the details about the metrics and also about the hedges. You know, the good news is that the learning objectives for this chapter sound an awful lot like last chapter. We're going to start with identifying some weaknesses to the single factor approach. And then we're going to talk about some new things like key rate durations and key rate O1s and partials and forward buckets. We'll do multi-factor hedging. I got a big spreadsheet for us to look at towards the end of the slide deck. And then we'll continue on there with some partials and forward buckets, and then we'll end talking about some volatility. All right, let's start with the obvious notion. What we assumed during that last chapter was that we were some kind of an investor in fixed income securities, and we're exposed to all different sorts of types of risk when we're a fixed income investor. The focus, of course, in this part is the interest rate risk factor. So what do we know? We know that when interest rates rise, when yields rise, the value of our bonds falls. You know, that's kind of the generic definition of interest rate risk. But as we found out in the last chapter, it's a little bit more complex because some bonds will experience larger price drops than other bonds for a similar increase in yields. And so what we were doing last chapter with this whole duration and convexity-based stuff was to assume that when interest rates changed, when yields changed, that they changed in an identical fashion all along the yield curve. So look at the picture there. We start out with an initial yield curve. Last chapter, we just assumed there was a parallel shift. In this case, it's a shift upward, but it could be a shift downward as well. Now, of course, the problem is that life doesn't approach us in parallel shifts, whether it's in our careers, whether it's in parenting, or whether it's in trying to decide what kind of an entertainment outlet you're going to have this weekend. Nothing comes to us parallelly. Not sure that's a word, but hopefully you understood that. So, of course, what we're going to do in this chapter is try to answer the question, what happens if, and look at the red line here, that long-term yields rise by a much faster rate than short-term yields. So we have this non-parallel shift of the yield curve, and not only can the yield curve steepen or flatten, but it can twist and contort and do all sorts of crazy things. And so really that's the weakness of that single factor duration approach, is that it assumes that there are parallel shifts. So what do we do? What do we do when there are non-parallel shifts? Well, I guess one of the choices is that we could just go to the beach and dig a hole and stick our head in the sand and say, geez, I hope interest rates don't twist too much during the life of the bond I own. But of course, that's not going to be a solution. That's what we're here for. We're going to try to figure this out. So what we're going to do is we're going to look at the yield curve, and we are going to identify key rate exposures for our particular investment horizon or our particular bond or a given set of yield curves. So notice that first block definition. The key rate exposures help us to describe the risk distribution along the term structure. Now, we're probably going to use government bonds, and we like to use government bonds, specifically U.S. government bonds, because they typically are issued pretty frequently, right? I mean, the total debt of the U.S. federal government now is way above $20 trillion. And so the government borrows multiple times a week. So there are tons and tons of these securities out there. But what we like to do is we like to identify these bonds that have been relatively recently issued so that they're going to be trading at or near par value. And that's going to be an important concept here. Remember, chapters and chapters ago, we talked about the par yield curve and the spot yield curve. That's going to play an important role here today. We're also going to look at these partial O1s. What these are going to do is they're going to help us measure the risk of a portfolio of swaps. I mean, remember, when you have this bond portfolio, suppose you have a 5-year bond and a 10-year bond and a 30-year bond, and you have this bond portfolio and you're trying to manage it, what you can do is you can look over in the swap market, go over in the derivatives market, and you can see lots and lots of similarities. So what financial risk managers do is they look at the fixed income market and then they look at the swap market and they try to see where those similarities and where those crosses and links are so that it's possible to combine the fixed income market and the swap market so that you can do things like, improve liquidity, you can do things like hedge, you can span. Remember, the spanning means that there are many, many more possible future values or outcomes. And then we spent some time on the forward yield curve. So we're going to look at some forward bucket O1s. And this is going to be pretty interesting. What we're going to do is we're just going to identify a multiple year period, like 2 or 3 year periods. And we're going to just throw all those forward rates into a bucket. And then we're going to try to use those buckets to help us value these fixed income securities and also to hedge. Look at that last circle point I have down there. Yield curve is divided into several defined regions or buckets. All right, let's look at this picture here. We got 0 to 30 years on the horizontal axis, and we're going up from 1 to 4%. So these are Treasury. This is a yield curve. So note we've got pretty big steep there, right? Upward sloping, and then it kind of flattens out. This is maybe a standard, maybe kind of a normal yield curve. What we want to do is we want to identify key rates along that yield curve, key rates that are really important to us. Now, the convention is to use the 2, the 5, the 10, and the 30. So those I have those blue asterisks. Can you pluralize that word so you can see those along the yield curve, and those are going to be our key rates. So that's pretty much the convention. There's nothing really interesting about 2, 5, 10, and 30. They just happen to be rounded numbers. I mean, you could pick 3, 9, 16, and 27, but the convention is to do what we've done here. And what we're going to do is we're going to assume that everything along that yield curve stays the same, except for that key rate. So we're going to select the key rate and say, what happens if that 5-year key rate goes up or down by, pick your number of basis points. The convention is to start with the smallest amount, 1 basis point. So what this is going to allow us to do is to determine value, right? The value of our bond portfolio based on changes in those key rates. So clearly this is a non-parallel shift, and it's a really, really small shift as well. But that, of course, is what we're trying to do as good financial risk managers and as good financial analysts. We want to be able to tell our clients, we want to know that if a key rate changes by a really small amount, it's going to have this impact on the value of the portfolio. I mean, that makes perfect sense. Now, we're going to work on a couple of problems here in a few slides, but I wanted to give you an example and a little bit of a heads up of what might happen to us as we work through some of these problems. Now, what I have done is in the slides, I've taken a bunch of the work from the actual chapter. This is not from the chapter. This is a little bit of stuff that I worked up on my own. So what I want you to consider is a flat yield curve, where the par yield and the spot yield are both 5%. All right. So think about that flat curve goes all the way from 0 all the way out to 30 or 50 or 100. There's talk these days that the U.S. government should issue 100-year Treasury bonds. So you got this flat yield curve. So let's suppose that we identify a 3-year key rate, and we want to know what that 3-year key rate duration of a bond is. And what we're going to do is add 50 basis points to the 3-year par rate. not the 3-year spot rate, but the 3-year par rate. And so just to remember, that means that we're adding 50 basis points, and then we're going to force the bond to be traded at its par value. Now, let me just go back here. What I've done is my asterisk is right on the year 3. So we're going to shift that year 3, that key rate, upwards by 50 basis points, but we're leaving everything else constant. So that's why I have the next bullet point there, that the 1 and the 2-year par rates remain at 5%, as do the spot rates. The 3-year par rate is going to increase to 5.5%. So what we want to do is solve for that 3-year spot rate. All right, so here's just a simple formula. Since we're dealing with par rates and par bonds, we're going to force this bond to sell for its $1,000 par value. So the coupon rate is now $55. So notice in the numerator, I have $55 in year 1, $55 in year 2, $55 in year 3, plus the $1,000 par value if we're considering a 3-year bond. All right, we're going to try to value that 3-year bond. So we'll divide by 1 plus the par rate and the spot rate, right, in year 1, raised to the first power, 1 plus the par rate and the spot rate raised to the second power in year 2, right, because they remain the same. But now we've raised that par rate to 5.5%. What happens to the spot rate? Now this is just some simple math, so you could, get out a scratch pad if you want and do the algebra, and you'll solve for that spot rate, 3-year spot rate, and it turns out to be 5.52%, which of course should make sense since we've raised the cash flows and we're discounting those first two at the lower rate. We need to increase that rate in year 3 to force it to $1,000. All right, there's not really a whole lot that's interesting in that part, but what we're saying now is that that spot rate has to increase up to 5.52%. But now here's where it gets interesting. Let's go ahead and consider the 4-year spot rate. All right, so we're back now under the assumption that the 1-year and the 2-year and the 3-year, those par rates are now back to being 5%. And let's see what happens to a bond, a 4-year bond, by solving for that 4-year spot rate. So we're back to a coupon of $50, right? So I have $50 and $50 and $50 over the first 3 years. Now we're going to discount them at the 5% spot, for years 1 and 2. But now we're discounting that year 3 because we've changed that key rate, right? That has to go up to 5.528. We're raising that to the third power. And then in the 4th year, we get the $50, the last coupon, and the $1,000. Solve for the 4-year spot rate. And if you do the math, notice what result you get. You get 4.98%. Wow. So the 4 years 0 coupon bond will have a slightly higher price when the 3-year par rate increases. So this is a little bit counterintuitive to what we're doing, but I wanted to work you through this quick example so that you get a sense of the non-parallel shifts and what it means to have a key rate change and the relationship between the par and the spot. Now, here's a good formula for the key rate, and this shouldn't be surprising to you. The key rate 01 is going to be the effect of a dollar change of 1 basis point shift. So we're going to do this formula. We had this in the last chapter as well. We're going to have in the numerator the change in the value of the bonds, and then we're just going to standardize it by 10,000 because we're doing it by the change in yield, and so that change in yield, 1 basis point, 0.0001, right? So let's work through an example here. Let's look at a May 2049. So what is that? That's 30 years from today of one of these stripped securities as of May of this year. So there's the initial value, 26.11485. All right, so what we're going to do is we're going to do a 2-year shift and a 5-year shift and a 10-year shift and then a 30-year shift. Remember, we're going to make those key rates, the 2, the 5, the 10, and the 30. Now, what I did in this previous example was just make up a 3. I could have done 5, but I really didn't want to have to go through all that stuff for 5 and then 6 years. So I just simplified it back in that example. All right, so let me just scroll back here. There's our formula for the key rate. So we recompute those values under changes in the 2, the 5, the 10, and the 30 years. And then we're just going to use that formula. And so we get key rates, the key rate 01s of, what is that, 001, 04, 024, and then 103. And then notice that those first 3 are negative. And so this is what I was explaining to you in that previous slide. So look at the bottom block point right underneath the table. How do we interpret that key rate for the 10-year shift? A negative key rate 01 implies an increase in value after a given shift. And so this C-strip, this stripped security, increases in price by 0.0024 for a positive 1 point shift, 1 basis point shift in the 10-year rate. So notice in parentheses I had that this is somewhat counterintuitive, but based on this example that I've given you back here, that should be kind of an obvious notion that we need to make certain that we compare and we differentiate between the par rates and the spot rates. I'm not so sure that the reading does it justice about those key differences. When you go through these readings and these complex readings in these chapters, there's always one sentence in there that might explain like the previous 4 paragraphs and then the subsequent 4 paragraphs. And so it's really key to focus on those important ones. All right, so let's shift over to key rate duration. So what is this? Key rate duration is going to tell us about an expected change in price when the yield curve shifts in a manner that is not perfectly parallel. And so how do we do that? We do that with those 2, 5, 10, and 30-year key rate exposures. So there's the formula. I think we had that up in the last chapter as well for key rate duration, and there's really nothing new or interesting about that. It's just a key rate rather than the entire duration. And so I think I've done this for, which one is that? Going back here, that's the 10-year. That's the 10-year shift. So there are the 2 prices, right? The 26.13 and the 26.11, right? So you get a key rate duration of 9.19. And those bottom formulas there kind of remind you of the relationship between and among these concepts, some of which we talked about in the previous chapter, some of which we're just doing right now. Now note that first block point. Interpreting each key rate duration in isolation can be quite difficult. Yeah, that's fairly true. And the interesting part of this is because typically the yield curve doesn't stay stable all throughout it except for one key rate. So it's unlikely that a single point on the yield curve will shift upwards or downwards. However, what this does, the reason that this is so important, is that one key exposure, that one shift, allows us to begin the process of seeing even more complex changes. But what it does is it allows us to compare the key rate durations across the curve. And the important end concept here is that if you take those key rate durations, like what did we do, the 2, the 5, the 10, and the 30, and you sum those, you'll get the effective duration of the portfolio. And that should make perfect sense, right? You have this 30-year bond, and you have these key rates. And if they're key at each different spot, they ought to sum to whatever the effective duration of the portfolio if you're measuring those changes at each of those 4 rates or 2 or 3 or however many you pick. All right, let's go ahead and complicate matters here just a little bit. So here's a section in the chapter on hedging. So let's take a look at a 30-year option-free bond. Let's make life as simple as possible we're paying semi-annual coupons of $5,000. So that's total of $10,000 per year, flat environment, 5% across all maturities. All right, so we're going to assume a 1 basis point shift in the key rates. So there's our initial value, $145,066. If we have a 2-year shift, our price falls to 145,061, and then 145,050, 144, and so on, all the way down to 145. Everybody get that? All right, so let's go ahead then and compute those key rates and then the key rate duration, because one of those learning objectives was to compute these things, and these are really simple. So let me just give you the simplest way to do this. You can go back and look at this formula, and you can look at that formula, but if you're given something like this, look at the price difference between the initial value and the 2-year shift. If you take the 145,066 and you subtract the 145,061, now go ahead and do the 45 minus 23. What do you get? 5.22. So that's going to be the key rate. So that's really just the difference between those two prices. And then you do the same thing. It's $15 and $77 and $65. All right. And then the key rate durations are going to be, here, now watch this. Let me go back. Where was that formula? Key rate duration. So notice how I got that 919 right there in the middle. You have to take the difference between the two, divide by an interest rate, and then divide by the initial value as well. So once we get that 522, just divide by the initial value. So if you whip out your calculator and do 522 divided by the 145,066, you'll get that 0.36. Although you'll have a bunch of decimals in there, so it might be 0.00, a bunch of zeros in there. But still, that's the key rate duration: 36, 109, 534, and 452. And then if you sum those, you get 1131. All right, so that takes care of that learning objective about how to compute those things. This is the simplest way to do it. Now, of course, if you're given other kinds of information, you may have to compute those things, those variables beforehand, but you ought to be able to come up with each of those columns. All right, so let's go and figure out how to hedge. Right? What are we doing? What did I start out this slide deck with? We have a bond, and we're exposed to interest rate risk. So how do we hedge? All right, so let's suppose that we have 4 other securities, each with the following key rate exposures. All right, so there's the 2, there's the 5, there's the 10, and there's the 30. And there are those key rates. And that table is replicated right up at the top there. All right, so the table we have right there at the bottom is the table up at the top. All right, so here's the question. We have this, what did we have back here? 30-year option-free bond. So why don't we do this? Why don't we hedge by finding the face value of the 2 and the 5 and the 10 and the 30-year securities that is going to find those face values that is going to eliminate interest rate risk. In other words, what we want to do is ensure the value of our portfolio. What was it? It was 145,066 today. So what we want to do is we want to take a position in those securities, 2, 5, 10, and 30, so that we are fully hedged. In other words, if rates go up by a little bit or rates go down by a little bit, the value of our portfolio remains at that 145. And we're going to do this with those key rate exposures, the 2, the 5, the 10, and the 30, which of course is just the convention. All right, so let's just start at the top here. This is going to be simple. We're going to take that key rate exposure for the 30-year bond. That's 0.2 all the way out. We'll divide it by the 100 per face value. We need to weight this. And we're going to multiply that by the face value of the 30-year bond that we need. All right, and then what we're going to do is we're going to do the same with the 10-year. We got the 10-year, we got the 0.1 divided by the 100 times the face value of the 10. All right, I'm just working my way down on those things. I'll get to the other parts of the equation here in just a second. Then for the for the 5-year, we're going to take the 0.45 divided by 100 times the face value of the 5-year security, and then the same thing for the 2-year security. So everybody see what we're doing. We're trying to find the face values of those individual securities that we need to hedge our investment in that 30-year bond. What we're going to do is we're going to set them all equal to 0, right? Set them equal to 0 so that we have no interest rate risk. And so if you just do the math in there, do some solving. So start down at the bottom left there in red. I've got that face value of the 30-year security is a minus 32,750. And then we keep working 77.43, 33, 317. And so what that means is that we need to short, that minus sign in front we need to short all those securities. That makes sense. We own the 30-year bond, right? So we're going to short all those securities. And notice my final block point down there. Only then would the initial bond position be insured from changes in rates close to those key rates used. Now, of course, the extra limiting assumption that we make is that what happens if the 17-year rate changes? Well, I'm not sure we're handling that here, but nevertheless, we're spanning that entire yield curve, right, with the 2, 5, 10, and 30. And so hopefully a 17-year key rate will kind of show up somewhere in there. Anyway, it should be obvious that this gives us a pretty good starting point, and it gives us a place to hedge. So we know that we can own a bond, and we know that we can hedge it with securities that have those key rate exposures. All right, so what did I just say? Look at that, the line there. Key rate hedging, I've got a star, 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 right? So look at the top block point. Key rate shifts make use of a few key rates to determine risk exposures and then to execute a hedging strategy like we just did. Now, let's suppose that here we are, we're looking at the fixed income market, and we're really smart. So we look over in the swap market over there and we say, wait a minute, there are lots and lots of interesting things that are going on in the swap market. Is there anything that we can use in the swap market to help us over here in the bond market? And of course there are. So look at the bottom line that I have star, 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 a bunch of stars. So those are partial and forward bucket O1s that are going to help us hedge with greater spanning, right? All right, so when swaps are taken as the benchmark for interest rates in these complex portfolios, right? Now, we didn't have a complex portfolio. What did we just own? Just that 30-year option-free bond. But of course, you guys know that these fixed income security portfolios can be pretty complex. So we're gonna measure the risk along the yield curve using the partial O1s or even the partial PV-O1s rather than just those key rates. And that's because, look, the swap market participants, they have the swap rate, once a day, I don't know, twice a day, 5 times a day, because they can observe those futures over in the futures market, and then they can observe the swap rates and then the par swap rates. So if we fit that swap rate curve, the sensitivity of a portfolio can be measured in terms of changes in the rates of all of those fitted securities. So that should make sense then that the partial O1s change in the value of a portfolio after a one basis point change in that fitted rate, and then a refitting of the curve, and then once again all those other rates are unchanged. All right, let's suppose that we've got this 3-month LIBOR rate and par rates at 2, 5, 10, and 30-year maturities, and we do this, using some kind of fitting algorithm, right? The 2-year partial O1 would be the change in the value of the portfolio for a 1 basis point change in the 2-year par rate. All right, so that's really important based on what I said to you earlier about the par rates and the spot rates. But of course, then the other rates, the 3-month, the 5 and 10, those are kept the same. Now, how about if we use these forward buckets? So look at the bottom. Look at those beautiful blue buckets. So what are we going to do? And we could define these buckets in any terms that we want, but the convention is to say, all right, let's do, pretty short term, and then a couple of medium terms, and then some long term. So our buckets are going to be 0 to 2 years, 2 to 5 years, 5 to 10, 10 to 15, and 20 to 30. All right, so what we're doing is we're going to take this term structure of the forward rates and we're going to throw them in a bucket. All right, so after that, then each forward bucket is computed by shifting the forward rates in that bucket by 1 basis point. We're not just throwing them together and then forgetting about them. No, we're keeping them in there. I mean, when you look inside of the bucket, you're going to be able to see the 2 and the 3 and the 4. You're going to be able to see those things, but they're in one bucket. And we're going to change that one bucket by the same amount. And you'll see this here in an Excel spreadsheet that I have. But notice what the bucket thing does. You put a bunch of rates in a bucket and you shift all of them upward or downwards by a small amount instead of doing that key rate exposure, which was just one rate that we started out. Now look at the last circle point. These could be semi-annual, they could be quarterly, they could be weekly. It really could be anything that you have access to the data. All right, you ready for this good example here? Let's take a look at some forward buckets. All right, what do we have? We have a 2.12% 5-year swap. And all we're going to do is worry about 2 buckets, the 0 to 2 bucket and the 2 to 5 year bucket. And what this does is this is going to give you just a little bit of an idea about all those buckets. Did you really want me to put an Excel spreadsheet together with all 5 of those buckets? It would have to be so small we would need binoculars so that we could see it. All right, so let's go through these columns. So down the left-hand column, there is the tenor of the swap, right? It's 5 years, so we start at 0.5 and then 1, 1.5. So every 6 months, right? There's the cash flow, 1.06. So this is like the bond, right? If this is a coupon payment, 1.06 all the way down to year 5, where we get the 100 par value and the $1.06 in the coupon. All right, so notice then the next column is the column of current forward rates, which we can observe, or we can compute, or we can estimate, right? We've done that in previous chapters. And then what we're going to do is we're going to shift our buckets. So notice in blue, I have the 0 to 2 shift. What we're going to do is we're going to add 1 basis point to that. So in your calculator, that current forward rate is, what is that, 0.01012 in decimal form. So add 0.0001 to that and you get the 1.022. Everybody see that? The blue column is we're shifting that 0 to 2 bucket up by 1 basis point. So remember I said you can still look at the bucket and they didn't get mixed together. You can still see those forward rates, but they're in the bucket. We're shifting them up together. Now note that the 2 to 5 bucket there in the next column, those are still the same as the current forward rates. All right, now let's go ahead and look at the 2 to 5 bucket. What we're going to do is take that forward rate, the current forward rate, and add 0.0001 to it. And in purple, that is the column of current rates plus the 1 basis point. So notice I've got the blue column as the first bucket, and I got the purple column as the second bucket. And then the 2 white columns above and below, the purple and the white, those remain the same. And then if we sum all those, we get that final green column over there. Then what we can do is we can sum those forward rates, and notice that we get, well, under the current forward rates, we get a present value or a price of, what is that number, 99.55. And then if we do that shift upward, the present value goes down 99.976. then 99.9679, 99.94, and so you can take the difference, and that's what I have down at the bottom, the 196, the 276, and the 472. That's going to be the entire, that's the difference between those kinds of prices. So do you see the sense here? You're able to determine the value, present value of whatever fixed income security you're looking at by using these forward buckets to shift rates either upwards or downwards. In this case, we shifted them up by 1 basis point. Now, I told you in that first slide or so that the forward bucket stuff is really, really cool. And so imagine a bigger spreadsheet where we have, here, let me just go back here, where we have all these different buckets, right? We've got 5 buckets. So our spreadsheet, we've got to go over more, and we've got to have the, the 5 to 10 shift and all those other shifts. And think about what this means in terms of how restrictive our assumption was in the last chapter that we had a parallel shift in the yield curve. With these forward buckets, you can do all sorts of crazy things. So this is really cool stuff. All right, so how are we going to hedge with all this kind of stuff? Here's the example that's given right out of the chapter. All right, so here we are. We have a 5x10 pair swaption. Oh my gosh. So what is this pair swaption? All right, so what were we doing before? We talk about swaps. That's just a regular old derivative. Now we have a swap option. This is a derivative on top of a derivative. I always tell my students I call it a double derivative. I don't really know. That's not any kind of an official term. But what this swaption does, it's a pair one, so it gives us the right, but not the obligation. Remember, it's an option. The right, but not the obligation to pay a fixed rate of 4.044% on a 10-year swap that's trading in Europe, a 10-year swap that doesn't begin for 5 years. The underlying asset then is a 10-year swap. That should make perfect sense. All right, so down here in Figure 1, we have these forward bucket 01s for just 4 different buckets. Okay, so even the chapter didn't want to go out to hundreds of these buckets. So 0 to 2, 2 to 5, 5 to 10, and 10 to 15. And those are all the forward bucket exposures that were computed much like we did in the previous in that previous slide. All right, so there are the exposures across that first row. So there's the 5x10 pair swaption. So there's the 4.04%. There's the rate, and so there are the exposures all the way to the right. Notice that I have in red there the 038, and that's negative. I have that for a reason. I'll tell you that in just a second. And then we're going to look at 5-year swaps, 10-year swaps, 15-year swaps, and then there's that 5x10 swap. That's the underlying asset, right? So the question over there on the right-hand side is, how do we hedge this pair swaption? All right, now what I'm going to have to do is I'm going to have to toggle back and forth. So how are we going to hedge this swaption? We're going to try to do it with some other swaps. I mean, that should make perfect sense, right? So this is what we're going to do. We're going to identify 3 different ways to hedge this swaption. And then we're going to try to figure out which is the best of the 3. All right, so forget about all the numbers on the right. Let's just make sure you see what's going on in the on the left-hand column. So in the dark blue at the top, there's the 5x10 pair swaption. And there are those forward bucket exposures. That's from the previous slide. Then I've got underneath it hedge 1, hedge 2, and hedge 3. So these are 3 different hedges. There's nothing really interesting about these hedges. You could come up with hedge 4 and hedge 5 and hedge 29 if you wanted to. But let's go ahead and suppose we're going to use in hedge 1 the 10-year swap. Hedge 2, we're going to use the 5x10 swap. And in hedge 3, we're going to combine the 15-year swaps. So imagine we've got this option, this swaption, right? And we're going to hedge. We're going to hedge with swap contracts. All right, at least from a big picture sense, I think we can all agree that those are okay. Now, what are we going to do? Notice hedge one. We're going to take the long position in a 10-year swap. So we're going to take 44.34% of the 10-year swaps. And so let's go back to the previous slide. That's why I have in red, and notice I have the 10-year swap in blue. If you look at that total exposure for our swaption 038 and divide that by the 10-year total exposure of 0857, you get, let me go back here, you get that 44.34%. And then if you take 44.34% of the, now go to the 0 to 2 bucket, and link that with the 10-year swap. What's that number down there? 0194. If you take, let me go back here. If you take 44.34% of that number, you get the 0086. So that's how you complete that row. And because we did the 44.34% of that, notice that the 2-year bucket and the 0 to 2 bucket, the 2 to 5 bucket, the 5 to 10 bucket, if you sum those exposures, you get 038, and it's positive. So over on the right-hand column, the far right column, we have a minus 038 and a plus 038 exposure. Those net to 0. So what have we done? We have fully hedged our swaption with that 10-year swap. Now, it would be awesome if that could be the end of the story. I'm going to come back here in just a second. Let's go ahead and just quickly do the hedge 2 and the hedge 3. And we do the same thing. So if I go back here, how did I get that 46.66% of the 5 by 10? I guess if you take the 038 and divide that by the 0815, that makes sense. You'll get 46.66%. Repeat that process over and over, and notice what you get. You get the same 038. So fully hedged again, 0 exposure on that far right column. And then let's do the hedge 3 just quickly. You can do the math here if you want to. We're going to take 57% in a long position and a 61% in the short position in that same swap. And that gives us the 67 positive on the long, 29 negative on the short. And I'm guessing that sums to 38 because that's 0 down on the bottom right. So all I'm focused on here is that far right column, and the fact that we have that net position of 0 exposure means that we are fully hedged. However, that means fully hedged over the entire forward curve. But notice, if we look at the individual buckets, look under hedge 1, that net position, we've got under the 0 to 2 bucket, we've got 96. The 2 to 5 bucket, we got 135. And we got a minus 043. We got a minus 0188. Now they sum to 0. But skip down all the way to the third hedge and notice how much smaller that net position is. So clearly, hedge 1 is not nearly as efficient as hedge 3 because each of those forward bucket exposures are now almost fully hedged. The total is fully hedged on all 3 of them, but now at each of those bucket points, at each of those forward bucket exposures, those numbers down at the bottom, look, 0.0002, minus 0.0010, that's pretty close to 0, right? And so that's what we're going to do. Look at that. Imagine that's what it says up in that second block point. The lowest net position indicates when risk is best neutralized. So that's the third hedge. Oh boy, didn't I tell you to take a deep breath when we started? All right, that was a lot of fun. That was pretty much the difficult part of this chapter. Let's go through and try to end on a positive note here. How about portfolio volatility? So just like, of course, there's a term structure for interest rates, there's a term structure for volatility. Typically slopes downward. We know that short-term rates are more volatile than long-term rates. But the cool thing about this, and this helps understand what we're trying to do here with these non-parallel shifts in the yield curve, is that those shifts are not perfectly correlated. All right, so how do we estimate those volatilities? So estimate volatility at each key rate, then compute the key rate O1s, and then compute the variance of the portfolio, and you do it this way. Look at the formula for variance there that I have blocked out, and it's the formula for variance that we had all the way back in the very first day of our investments class, where we have something squared times the variance, and then we have something else squared times the variance. A lot of times those are weights. Now, what these are going to be here is that those are going to be the KRO1s. That's the key rate 01. And we're going to square that. And then we have to have 2 times the correlation coefficient. Notice we got the rho in there. And so that completes our definition for volatility and our calculation for volatility. Oh my goodness. So that takes us through those learning objectives. That was fun for me. Have a great day.